So then I can edit it. Let's say I name it as kawasan. Okay. And also, let's say I want to have sloping. So just double click. So page number 2, I want to have sloping. So I have sloping, auto sloping. I will say yes. Okay. Direction, whether to slope outside or slope into the platform. Then the cut and fill ratio we can edit. Okay. If say no sloping, it means we cannot edit. Okay. No sloping, that means it's a retaining wall. Okay. So then for edge number 1 and edge number 4, change to sloping, yes. And go to cut section view, immediately we will have this sloping. Okay. And then the area will automatically add in here. Okay. This is very fast. You can set the setting in the parameter. So under the typical slope, you can set the firm cut or fill depth. That means after 2 meter depth, you will have a 1.5 meter length, the firm length, 1.5 meter. Okay. Then we have the cut slope, fill slope, and maximum height. All this we can set. Okay. Come back to input. So the next one, this is a road. So in EW3D, the road we cannot do alignment. You only can draw a box for one road. If you have different sloping, maybe you can draw 2 boxes. So with a different value, slope value. Okay. So for this road, I will key in the name, road, and then the type. The type is for 3D purpose, 3D view purpose. Okay. So if I assign to road, it means the color will become gray. So if I assign to residential, it become red color. Okay. Then the height. So I can open up the tracing. So you can see the height from edge number 1 to edge number 3. Edge number 49, edge number 3, 48. So we can double click and then we can change the levels for edge number 1, 49. Edge number 3, 48. So slanting down. Okay. Just like slanting beam. Next, we can edit the house. Let's say this. Let's say this row, and name it as house 1. House 1. Okay. And this row, and name it as house 2. The type should be residential. This house platform. Actually, we can add more platform. Let's say this one back lane, you want to have another platform. So I just snap it and model a new platform for the back lane. Okay, so after we model it, we can key in the height, means the proposed level, and then the name, okay, I can name it as back lane BL, then the height. Then for road, we can edit the subgrade. Okay, let's say 0.3 for all the cashier run, all this. Then later on will minus up in the volume. Okay. So also set in the subgrade. Okay, so that's all. We can add more cut section. Let's say I want to order cut section parallel to this line. Okay, then the same, we can extend it. Extend it longer. Then we can say I don't want full line, say false. And right click, we can add more transaction. So add up to here. In every 5 meters, for example, we have 1 transaction. Okay, so after we cut, immediately go to result, transaction view, all our 29 transaction is here. Okay. So our software is, you can say, very simple software. Everyone can easily master this software. For 3D view, okay. So before analyze, we don't have any 3D platform level view. We analyze it using so same after analyze we will have this meshing, and then we can view in this 3D platform level view, 3D view with the platform level. So the report, same we will have this cut, bank cut, expanded cut, and 1.1 hectare, bank view, volume needed, and 0.9. The bill calculation, we have this house 2, house 1, house 1, road, lane. Okay. So this is without sloping. We want to have sloping on plan. We can turn on in the analysis. Auto slope we can go through. And we can analyze again. Same and we use DPM. Okay. So after analyze, we will have this auto sloping on plan. So in our Excel report, you can see we have extra for auto sloping volume, the slope volume for cut and for fill. Okay. So that's all for this earthwork software. If you have questions, you can note down because today we have time and ask in the Q&A session. So the next software is our water reticulation software. So when we talk about water reticulation design in Malaysia, we only have this, you can say, two formula, the most important one. First one is a Hardy-Cross method for the looping. Second one is the Hazen-Williams formula for the friction loss and the flow rate calculation. So for example, we have this one loop, this project is only one loop. And first of all, we need to know the direction. So I just want to show how tedious if we using the manual calculation compared with our software. So for one loop, we need to know what is the flow rate first for each node. Each total up is 0.884 liter per second. So this is very simple. Q1 equal to Q2 plus Q3 plus Q4 plus Q5. Then we need to make an assumption. So let's say I assume 2 to 5 and 2 to 3 is the same, 0.3315. 3 to 4 and 5 to 4 is the same, 0.1105. Okay. But the direction different, so some is negative, some is positive. I'll show later. And then we need to know the diameter and the length. Okay. So we assume it's 150, all 150. Then I assume the maximum unbalance is 0.1%. Okay. Normally we do manual calculation maybe 5% or 2%. This is good enough. For this project, I assume 0.1%. Okay. Then we can plug into the formula. We have two formulas for Hazen-Williams. First is to get the heat loss. Second is to get the discharge, the flow rate. So for first try, for the first looping, so we plug in all the value into the table. Then we can plug into the formula. We get the head loss. And then HF divided by Q. So we get the total. Then we can plug into the second formula, the correction. Okay. So finally we get the correction value, negative 0.04214. Then we can plug into the formula. It means Q minus delta Q. So we get the corrected Q. So the different percentage You can see it's all more than 0.1%. So we have to do second try. Normally we do a manual calculation, we have to try many times. So this is more than 0.1%. So proceed to the second try. So we get the assumed flow rate, and we plug into the formula, same, you get the head loss, and then plug into the fraction delta Q. And after that, in this table, you get the percentage. So all more than 0.1%. Except these two is less than it. So we have to, no choice, I have to do another try. So the difference of two value is more than 0.1%. So the third try, same, we plug in the assumed flow rate, and then we get the head loss on it now. And plug into the correction delta Q, and we get this 0.000001414 liter per second. Okay. And same, and we can get the corrected Q. So this time is less than about 0%. About 0%, so it's less than 0.1%. So this time okay. So only for one loop, we have to try 3 times for this project. Okay. So imagine if you have a lot of looping, so you need a software. So in our software, same, we adjust the maximum time balance to 0.1%.